All right, we're going to look at this next example, and we're going to, this example is oblique asymptotes. And what we're going to do is we're going to sketch the graph. And I will look at this function here, y equals x squared minus 5x minus 6 divided by x minus 2. Okay, so let's go through this. Let's start off with zeros with x-intercepts. So all we have to do here is factor. I was sort of hemming and hawing because I was thinking, how's this going to factor? Okay. We factor and we set this equal to 0. Let me write it on the next line. So I get x minus 6, x plus 1 equals 0. So this gives x equals 6, x equals negative 1. Those are our zeros. And then we can write the x-intercepts. So those are zeros. X-intercept 6, 0, negative 1, 0. Alrighty, and then we can look on the domain. The domain we can just see right away is where the function is undefined, and that is where, I mean, the domain is everything. It's all real numbers except where the function is undefined. So that would be all real numbers except for 2, because 2 minus 2 makes 0. So we don't want that. So it's all real numbers except where the denominator is 0. And that will lead to the vertical asymptote. Okay, now, for y equals x squared minus 5x minus 6 over x minus 2, the degree of the numerator is greater than the degree of the denominator. This is just greater by 1. So if it's just one more, this gives an oblique asymptote. Some books call it a slant asymptote, but I like the word oblique. It sounds French. It just sounds nice. And so what we're going to do is long division, which we've done before, to see what's going on. And this might be the part that people don't like. You can use synthetic division also. So x times x makes x squared. So that's going to set me up there. And add the opposite. So I want to get that right. Okay, minus 3. So then we get negative 3x plus 6. Add the opposite. And then take that remainder and put it over the divisor. So what this tells us is that y equals the line x minus 3 minus 12 over x minus 2. And this guy here, the x minus 3, gives us a line, which is the oblique asymptote. Okay, what is an oblique asymptote? It's a line. And the idea behind this is that as x gets large, negative 12 over x minus 2 becomes almost 0. If I were just looking at negative 12 over x minus 2, I'd say that that has a horizontal asymptote y equals 0, the x-axis. Because as x gets large, this becomes like, say x is a billion. 12 over a billion is almost 0. This turns almost to 0. And what we're left behind is x minus 3, which is a line. So this is it's a line, it's an asymptote, which is a line, but it's not a horizontal line, it's not a vertical line. Hence, oblique. Although, I don't know if everybody knows that word. Okay, so let's move on to making a sign chart. Oh, gosh. Okay. Let me use this other pad for the sign chart. Okay, so for E, I'll do sign chart. And so I still have y equals x squared minus 5x minus 6 over x minus 2, which we already factored as x minus 6 over, or times x plus 1 over x minus 2. And what we do is we draw a number line and we make dotted lines at the zeros and dotted lines at the vertical asymptotes. So 2 was a vertical asymptote, and the zeros we found were 6, and -1. -1 was a 0. And then we plot points. So this is can be a little bit tedious. So anyway, we put in -2, -2 minus 6, -2 plus 1 over -2 minus 2. So that's going to be -8 times -1 over -4. 3 negatives make a negative. Don't even really care that much what the number is. Or maybe I should, because I can later on sketch the graph. So I shouldn't just sort of dismiss that without having any interest at all. That makes -2. So it's also just good to plot points. I can use these numbers later when I'm, like here I put in 0 and I'm going to get the y-intercept. So when x is 0. So the y-intercept is that. So this is positive, and so the y-intercept is 0, 3, so that's a good one to know also. And then put in 3. Okay, so this is going to be -3 times 4 over 1, so that's -12. So that's negative. And then beyond 6 is 7. Okay, so I'm filling in, so the function's going negative, positive, negative. Okay, I think the other one's going to be positive. So I'm going to get 7 minus 6, 7 plus 1, 7 minus 2. So that's 1 times 8 over 5, and that's positive. Alrighty. Okay, so this is going to, okay, what does that mean when the function's negative? This is the function f. The function f is negative. That means that the curve, when you sketch the graph, is going to be negative. Y will be negative, so it's going to lie below the x-axis. Over here, the curve will lie above the x-axis. Here below the x-axis, above the x-axis. That's what those mean. All right, so now we put it all together, and that's sometimes a bit of a challenge. Okay, which is, we're going to sketch the graph. And that's F. Sketch the graph. So what we have is we have 3 different ways of expressing this function so far. X squared minus 5x minus 6 over x minus 2. I don't know why I said 5 so far. I think this might be it. Maybe there's other ways, but I think we've done them all. So we have this guy here. There's some advantages to this. But okay. Anyway, we have also this expression. But then we also did long division, and that gave us oblique asymptote, but with long division, we got x minus 3 plus negative 12 over x minus 2. So just by doing these, having these three forms, actually we get so much out of this. From here we can see what the zeros are in the vertical asymptote, and from here we can see what the oblique asymptote is. So, okay, the problem is I feel like when I do this, I have to make the scale sort of small. If I don't, it's not going to come out very good. I'd say usually what I do is I do this once, I get it wrong, and I redo it. I feel like really often I need to do it more than once. But anyway, let's see if I not do that this time. Okay, so the oblique asymptote is a line y equals x minus 3. So I am going to start off with that oblique asymptote. And I'm going to make the scale sort of the spacing on the x's and the y's small, because you really have to get a big picture of this. So that's the oblique asymptote. Of course, we have to know how to sketch a line. Otherwise, we're sort of stuck on that. So, you know, y-intercept negative 3, slope 1. All right. So then what else did we have? We had the vertical asymptote, which is at 2. All right, so actually, see, x minus 3, because it has slope 1, we can see that this is going to be 3 right here. And then x minus 2, that's going to give us the vertical asymptote of x equals 2. I'm going to write up here, VA x equals 2. And then we had a 0 at 6. Now the thing is, I put that 6, 0 before I drew this. Maybe I'll end up having to write through that, but okay, just have to risk that. All right, now let's then go back to the sign chart at the same time and figure out what's going on with that. Although, truthfully, maybe this tells us everything. Maybe we don't even have to use the sign chart. So, I'm trying to get the sign chart here. Okay, see, the function is going to go negative, then it's going to go through a 0 and become positive, and then negative, and then positive. But you can sort of see that over here, that it's going to have that. Because look, what does it mean to have an oblique asymptote? That means the function is getting very close to it. So over here, it's very close. And then it somehow has to get to the 0. So it's going to come along here. And then somewhere along the way, we determined that okay. Somewhere along the way, we determined that the y-intercept is 3. Negative 6 over negative 2 is 3. So I will put that there. I mean, you can always plot some points, but you have to see what's going on. Now, according to our sign chart, the function is positive. First of all, it had to be negative over here. Then it had to pass through, and so then it becomes positive. I better just put that where it was. Okay, then it's going to go up. Why would it go up? Because it's positive. It can't go down. It would have to go down. It would have to pass through the x-axis again and have another 0. There's no other 0. Now on this side, we're going to be close to the oblique asymptote. Now how do I know which side? Well, I mean, how do I know what's a little bit above and not below? Because I had to go from here to here. So this I have to go from here to here. So it's going to be, and then it passes through. But also we have the sign chart to look at that. So we're going to see between 2 and 6, it's negative, but it's going to go down then. Okay, that was something. Maybe one of the more challenging things going on here. So what do I think is good to label? It's good to label the asymptotes, the zeros, or the x-intercepts, and the y-intercept, and here we have the oblique asymptote, and then label x and y. And that is, I'll just write it one more time. That's our function y equals x squared minus 5x minus 6 over x minus 2, which is the same as x minus 6 x plus 1 over x minus 2. Alrighty.